Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. Now take that easiness with a grain of salt because this is considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Gold Arrows by Marty Sears, and here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, we can get column, and box. The number on a gold arrow indicates the sum of the first x digit seen in the direction of the arrow, where x is the first digit seen. So this is, I think, x sums, essentially. But the arrows are not all outside of the grid. None of the digits which form the sum may be consecutive. So it's an Abner constraint, which is opposite of Renban. A number on an arrow outside the grid may contain 1 or 2 digits, right? So that's why. So normally, x sums usually are usually unconstrained, but in this puzzle. So okay, let's explain first of all what x sum is. So for these arrows, these are normally x sum arrows, and basically it is equal to whatever the number is equal to the sum of the first x digits it sees in this direction. So if this were to be, say, a 7, this would add up the first 7 digits, and that sum would equal whatever is on the arrow. Now, so this would be, so if this was, I don't know, say 7, 5, 6, 6, 3, let's just make it easy, 8, 4, 8, 9, and 4. This would have to, the number on the arrow, which is normally behind the arrow, but anyways, would have to be 42 because it would sum up all of the first 7 digits, which is set 3 through 9, which is 45 minus 1 and 2, which would be 42. So therefore, another example of this would be, say this was 3, and then this is 5 and 7. These 3 would have to add up to 15. So this number on the gold arrow would be 15. Now that he has gold arrows in the grid, which means that the digit here must be the same, must equal the sum of the first x digits that are seen in this direction. So it's also similar to these, except that these can only be a single digit. Remember, because it has to be 1 through 9 from normal Sudoku rules. That leads to certain implications with it. So I won't go into too much detail there, but just remember that these act similarly to these arrows, but you're limited in what the number can be on these golden arrows inside the grid. And there was a final stipulation where, since these are all golden arrows, none of the digits which form the sum may be consecutive. So this example that we had earlier of this being 7 and 3 through 9, whatever it was, 5, 9, 4, this does not work because these are consecutive. So the sums that are adding up to all of these sums, all of these arrows, cannot be consecutive. And that's a very important constraint. So a valid example would have been actually the second example I gave, which was 3, 5, and 7. Or 3, 5, 8 works too. So let's go with 3, 5, and 8. That's saying that the first 3 digits must add up to whatever the sum of this golden arrow is, which would be 16. And they're not consecutive. So 3 is not consecutive with 5, which is not consecutive with 8, which is not consecutive with 3 again. So that's very important too. And usually Nabner lines are, so this is called the Nabner rule, which is the opposite of Renban, because Renban requires everything in the set to be consecutive. Nabner requires everything in the set to not be consecutive. And instead of being on a line, it's basically the Nabner X sum, I guess. Yeah, and those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. So, these are all digits which have to have Nabner qualities. That means any cell in the grid that has an arrow, the next cell has to be 1, 2, or 3. Because you can never have 4 digits adding up to a single digit. 4 unique digits adding up to a single digit. So therefore, this must be 1, 2, or 3. This must be 1, 2, or 3. And this must be 1, 2, or 3. Same here. This is 1, 2, or 3. 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 Oh, but it can't be 1. If it's 1, right, it has to be 2 or 3. If it's 1, you just doesn't work. Right? Because then the sum would be 1, and therefore you'd have 2 1s in the same row or column. So these all have to be 2 or 3. If it's 3, it has to be with 9 then. Right? Because for Nabner to form for 1, 3, and 5, it has to be add up to 9. Right? Because you can only have 3 with 1 and 5 because it's Nabner. 2 could be with a variety of things. It could be 2, 7, 2, 6, 2, 5, 2, 4. Yeah. And interestingly enough, so if this was 3, it would have to include 1 and 5. At least. So if this was 3, this would have to be at least 5. Or at most 5, sorry. But the problem is with that is if this is 3, this becomes 2, which forces this to be 3, which means this would have to add up to 9, which is not possible. So therefore, this can never be 3. Therefore, this must be 2, and this must be 3, which makes this 2, and this is 9, again. So this has to be 1 and 5 here to add up to 9. This is 2. This is 2. So it has to be with 4, 5, 6, or 7, but the problem is it cannot add up to 9, so therefore 7's out. This could be 4, 5, or 6, but it can't be 7 again because this would have to add up to 9 also. We also know one of these two is 9, right? Because it has to be 3, 1, 5. So one of these two is 9. And one of these two is 9 because it has to have 3, 1, 5. If this is 3, this would be 2. So say this was 3. If this was 3, this would be 2, which makes that 3. Since this is 3 with a Nabner quality, it has to be 3, 1, 5 as an X sum. So this would be 9, but this would have to be the same. Therefore, this would be 9. Therefore, this one cannot be 3. Therefore, it has to be 2, which makes this a 3, which makes this a 2. So this is 9. This would have to be 1 and 5 here. So this is 2 with, what could it be? 4, 5, 6. It cannot be 7 because, again, the 9 can't be there. So this is 6, 7, or 8. This is 6, 7, or 8. This actually has to be 4, 5, or 6 also. So this is 6, 7, or 8. This is 4, 5, 6. So this is 6, 7, or 8. We have a 6, 7, 8 triplet now in column 5. So the rest of the column cannot contain 6, 7, or 8 also. So this can't be 6. This is 1, 3, 4, 5. This is 1, 3, 4, 5, and this is 1, 3, 4, 5, but there's no 3 possible here. So we know the 3 has to be one of these two. This can't be 8 anymore because the 6 is no longer allowed. This could be 3. We're not sure. Let's see. So this has to be not 1, 3, 5, or 9. So it could be 2, 4, 6, 8, or 7. 2 obviously can't be here. 2 can't be here. Let's see. This cannot be Nabner. So there cannot be a 4 with a 3 here. You could have 1. You could have 2 out of 5, 6, 7, and 8. That works also. So yeah, we just don't know. Oh, the Nabner lines can never be greater than the Nabner x sums. The next digit can never be greater than 5. Right? Because you can only have 5 digits which are unique, which are not consecutive with each other. That at most. So therefore, this must be 4, and this must be 2 then, because it can't be 6, 7, or 8. So this is 6, 7, or 8. This is 6, 7, or 8. This is 2. This is 4, so this can't be 4, which means this can't be 6. 4 cannot be with... 4 could be with a lot of different digits, though. 3 can't be here. So 3 is one of these 3. You could have... Oh, one of these is 5. So the 3... Well, If this is 5, this would have to be with 6, which is not allowed on the Nabner x sum. So this one cannot be 5, which makes this a 1. So therefore, this is a value of 1, and this is 5, which means this must be all the values. This can't be 7, so therefore this can't be 5. So this is either 4 and 6, or this is 6 and 8, which means 6 can't be here. So therefore, this is 7, which forces this to be 5. So this can't be 5, this can't be 5, this can't be 5. These can't be 7, therefore this has to be 8, which forces this to be 6. This can't be 8, so this is 6, which forces this to be 4. This can't be 6 anymore. This can't be 6 anymore. Where is a 6 in column 1? It has to be here. Also, we know all the odd numbers have to be added up with 5 to form 25 here. So this is 1, 3, 7, and 9, but 1 can't be here because this can't be 1. This can't be 3 because 2 and 3 are consecutive, and they would have to add up together, so this can't be 3. So we know 1 is here because this is 2, 4, 6, 8. 6, 8. 2 can't be here. You have a 4, 6, 8 triplet here in column 2, so this must be a 2. This can't be 1. The 1 has to be here, remember, because of the Nabner rule. So this can't be 1, so this is 5, which makes this a 1. 5 can no longer be here. Whereas a 5 in box 1, it has to be here, which makes this a 7. Okay. 4 cannot be here, and it can't be any of these, and it can't be here. So where's the 4 in box 7? It has to be here. So this can't be 4, so this is 1, which means this can't be 1. We can remove the 3, 4 part. So this can't be 1. This is 3 or 4. If this was 3, this would have to be 4. So this cannot be 3 because that would violate the Nabner rule for the x sum. Because this would be 3 plus 4, and 3 and 4 are consecutive. Therefore, this must be 2. Let's see. This is either 9 or 11. This is 4. Okay, so this can't be consecutive with 2, 4, or 6. Therefore, it cannot be 1 or 3, and it can't be 7, so this must be 9. Which forces this to be 7, which forces this to be 8, which makes that 7. So this has to be 1 now, and therefore this is 3. So that makes this a 9. So this is now 3 and 8. This is 3 and 8. Right? Because the Nabner rule would have to be violated there. Therefore, if that's 1, 3, or 7. So therefore, it had to be 9. This is 9, because it's 2 plus 7. This is 4 plus 9 plus 6 plus 2, which is 21, I believe. 8 plus 12. 4 is 12, plus 9 is 21. Right, so 21 works there. This is 8, 2 and 6. This is 7, 2 and 5. Okay. This is 3. This has to be 1, 5, or 7. Can't be 1, though, so this is 5 or 7. This is 1, 5, or 7. It can't be 7, though, over here. Can it be 5? No, because 2, 4, and 6. 4 and 6 would have to be here, so this cannot be 5 because of the Nabner rule for the x sum, so therefore this is 1, which forces this to be 1, so this can't be 1. This cannot be 1, 2, 3, so it must be 4 or 5. If it's 5, the problem is you don't have 5 even numbers, which would have to be even because they have to be non-consecutive. You don't have 5 even digits, shall we say. So therefore, this must be a 4. 2 and 4, so this can't be 1, 3, or 5. 6, 7, 8, and 9 could be here. So this could be 7 or 8. But if it's 7, there's no longer any valid number that can be added to this x sum, which would not be consecutive, right? Because 2 and 4 eliminate 1, 3, and 5. 7 eliminates 6 and... I guess it could be 9. Okay, never mind. Hold up. So this could be 9, or it could be 6 with it. Actually, that does work. Okay, so then this is 5, 7, 8. Oh, okay. This can't be 7 because of this 7, so therefore this has to be 8, which forces this to be 6. So this can't be 8, this can't be 7, so this has to be 5, which makes that 7, which makes this 5, so this adds up to 15. These add up to 20, with 2, 8, and 4, 6, so this is 20. This has to be... So these cannot be... have to be less... 5 or less. And this can't be 5 because it doesn't have a 1 to go with it. So it cannot be 1, cannot be 2, could be 3 or 4, but it cannot be 5 here. This could be 1, no 2, could be 3, could be 5. So all of those still work for this Nabner x sum. 3 has to be one of these. No, it has to be one of these two. Okay. So this is 8. This adds up to... There, 2 and 6. Therefore, this can't be 8. So this is 3, which makes that 8, which makes this 4, which makes this 3. This is now 5 or 9. This can't be 5, so this is 9. Therefore, this is 5. This adds up to... This is 1, 4, 6, and 8. Not. So this can't be 4, 6, or 8, which forces this to be 1. So this can't be 1. This is now a 4, 6, 8 triplet in box 2, so this has to be 1, 3, and 9. This can't be 9, this can't be 3, this can't be 1. This has to be a 5, 7 pair, but this can't be 5, so this is 7, this is 5. This is, what, 3, 6, and 9? Yeah, 3, 6, and 9, and this is 2, 7, 8. This can't be 2, this can't be 8. 5 cannot be here, and 5 cannot be here, and 5 can't be here, and 5 can't be here. Therefore, this must be a 5, which forces all the odds to be here. So this is 1, 3, 7, and 9. This can't be 3 or 9, so this is 6. This can't be 7, so this is 8. 1 can't be here. This can't be 1, 3, or 7, so this is 9, which means 9 cannot be in the rest of the column. This can't be 6 again. This can't be 8. So this is 1, 3, and 7. This has to be 4 and 6. So 1 cannot be here. 3 can't be here. 7 can't be here, so this must be 3, which means this can't be 3. So therefore, this can't be 3. This is 4, which forces this to be 6. 7 can never be here. 3 can never be here. It's 3 and 7 can't be here. This can't be 3, so this is 9, which forces this to be 1, which forces this to be 3. This can't be 4 anymore, so this is 6, which makes that 8. Therefore, this is 1, which forces that to be 7, forces that to be 1. This can't be 1. This can't be 6, so this is a 4. These can't be 6, and these can't be 8 here. We need a 9 in one of these two. 9 could be here. Okay, so what are these numbers? This is 2. So we have a 6 here. We have, what, 2, 8, and 9. So these can't be 2. So this is 8 or 9, and if you had the other 8 or 9 with it, then that would not work, because then they would be consecutive. Therefore, this must be a 2. So this cannot be 2. So this can't be 2, so therefore this is a 7, which forces this to be 2, which forces this to be 3. Forces that to be 7, which makes this a 9. This is a 3. This has to be 8 now, so it's 2, 4, 6, 8, which would mean this adds up to 20. This is 5, so this adds up to 25. This can't be 8 anymore. This can't be 8, so therefore this must be 4. This must be 8, which makes this a 6, this a 4. This has to be 9, and that's a 6. Wait, did we mess it up? 1, 2, 3, 4, 5, 6, 7, 8, 9. 2s. 3s. 4s. 5s. 6. 7, 8, and 9. And they all work with Sudoku rules. Oh, it's because I have these extra values. Yeah. Okay. Ah, I guess I have to put them in lowercase values. Anyways, that's the solution. Yeah, fairly straightforward. You're very limited with the Nabner xsum rule, and the arrows being inside of the grid. So that leads to some fairly straightforward solving. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.